Now, the first thing we're going to do in this chapter is find some particular solutions to differential equations. Now, suppose I tell you that I have a differential equation of the form y double prime minus y equals 0. Is this y equals sine x a solution to this differential equation? Well, the first thing you have to do, I need a y double prime and a y. So I have y, so I find y prime, derivative of sine is cosine. And I find y double prime minus sine. Well, it's looking promising. So when I put in y double prime minus y equals 0, I have minus sine of x of x is equal to minus 2 sine x. Oops, no. This is not a solution to this differential equation. Now, what differential equation would this be a solution to? Well, maybe if I had done y double prime plus y equals 0, then I would have minus sine of x plus sine of x equals 0. So you need to be careful and keep your signs straight. I make a lot of mistakes with signs, so we'll see if y'all catch me. Now let's see if this y is 4 e to the minus x is a solution to y double prime minus y equals 0. Let's see. I need y prime is minus 4 e to the minus x, and y double prime is 4 e to the minus x. So y double prime minus y is equal to 4 e to the minus x minus y, which is 4 e to the minus x. Aha, yes, this is a solution. I'm very happy. All right, let's try the general form of this. Let's see if the general form of y equals c e to the x is a solution to this equation. And it's general because I have this variable c right there. So y prime is c e to the x. Y double prime is c e to the x. So y double prime minus y is equal to c e to the x minus c e to the x. Aha! So yes, this is also a solution to this differential equation, and it doesn't matter what c is. It doesn't matter if c is positive or negative. Kind of cool. Now, I want you to determine whether this is a solution to this differential equation, and this is y to the fourth. So you're going to do y prime, y double prime, and then 1, 2, 3, 4, y to the fourth. Right? Good luck. Stop the tape when you're done. Now we're going to see if we can find some particular solutions to differential equations. What I mean by that is, suppose I'm given a differential equation, the second derivative of y minus y equals 0. Does this particular formula satisfy this differential equation? Remember, a differential equation is any equation where we have y prime and x in equation format. Well, the first thing you have to do is find y prime, and this is derivative of sine is cosine, and y double prime is derivative of cosine is minus sine of x. So when I add y double prime minus y, what do I get? Y double prime is minus sine of x, minus sine of x. So this is minus 2 sine of x. So no, this is not a solution to this differential equation. All right, let's try this one. Y is 4 e to the minus x. Is that a solution to this differential equation? Well, y prime is minus 4 e to the minus x, and y double prime is positive 4 e to the minus x. So y double prime minus y is equal to 4 e to the minus x minus 4 e to the minus x. We're in good shape. This equals 0. So the answer is yes. This does solve this differential equation. Well, I like this equation so much. What if we try the general form? And the general form just means that we have some constant in here. And, I mean, it could just be 4. e to the x that solves this. So let's try, oh, and this is e to the x, so this is actually a different equation. So y prime is c e to the x. Y double prime is c e to the x. So y double prime minus y is equal to c e to the x minus c e to the x, which is 0. Nice. So this is a solution to this differential equation. Now what if we go back to our other formula? Y equals c e to the minus x. Do you think that's a solution? Let's try it. Y prime is minus c e to the negative x, and y double prime is c e to the minus x. Aha, do you see a pattern here? So now y double prime minus y is equal to c e to the negative x minus c e to the negative x, and that is 0. So both of these are solutions to this differential equation. And that constant gives us a general solution. But, okay, first of all, you try. When you're done, stop the tape, do the problem, and then return, because we're going to work on particular solutions. All right, suppose I now want to find a particular solution to this differential equation, and I'm going to tell you that y equals c x cubed is a solution. I'm going to show you how you can find these solutions later, but for right now, the first thing we need to do, I have x, I have y, so I need y prime. So y prime is 3cx squared. So now let me plug in to x, y prime minus 3y, and see what I get. I've got x, y prime is 3cx squared, minus 3, and y is cx cubed. So this is 3cx cubed minus 3cx cubed, which is 0. So yes, this does solve my differential equation. You always have to check that, because if it doesn't solve it, then finding a particular solution is rubbish. All right, so I have y equals cx cubed. If I solve this for c, I've got y divided by x cubed. So to find my particular solution, I put in my initial conditions. Now, initial conditions are simply going to be a point on the curve that satisfies the equation. So this is 2 divided by negative 3 cubed. So c becomes 2 divided by negative 3 times 3 is 9, 27. So my particular solution is y is equal to minus 2 divided by 27. Did I say 27? Because I wrote 29. X cubed. Now you give it a go. Stop the tape and you're done.